Classes and objects are closely related to each other because basically class instance is an object. Classes in general hold together both code which describes information about class or about object and behavior. It means that object or actually classes describe a kind of data type which uh, can which we could use for variables, declaring variables which can not only keep some kind of information about their state, but which could as well just to do something. So for this reason, we can say that this is about behavior as well, not only about information as such. Okay, so we have classes. Class instance is just object. So if we have class, this is just a blueprint of object. And to have object, we need to produce somehow class instance. First of all, if you would like to compare two class instances, it means two objects, we need to use special comparison operator, which is built of three equal signs, not two, but three. And this is only used if we would like to compare objects. And this is a simple example. Class in general, if you would like to declare and define class, we need to use keyword class, name of the class, and curly braces, as we can see here. And inside we have block of code which is usually what we have there is a declaration of properties. It means variables which we call properties because they are in class. So properties and functions which are called methods because again they are inside the class declaration or definition. So this is a kind of method. This is just function, but because of this political reason it's called method. Name of the function, everything here for method is what is true for functions is true for methods as well. And this is a kind of property which is initialized here. It's just declaration and we have initialized it with value shape. This is very primitive class. This is just to have something to start with. And if you would like to create object or instance of class, we use this method. It's variable name of our object, and this is data type. In our case, this is shape. This will be class, and we have our class with parentheses. It means this is default initializer. I will explain later what does it mean, what it means. If there is no definition for, no declaration for initializer, it means we use default initializer. It is just empty parentheses here. And this way we have created object shape 1. The same way we create objects shape 2 and shape 3. Actually, shape 2 only, and shape 3 we can create by assignment to shape 1. And shape 1 should be the same like shape 3, but shape 2 is different than shape 1, which we could check using this comparison operator, and we have false here. It means the two objects are different, and shape 3 and shape 1 are the same, and we can check it, shape 1 and shape 3. We can see result of this comparison is true. It's true because the two objects are the same. For object shape 2, it's not the case because, as we can see, this is completely different instance of the class shape. Inside instance, we could use some variables, which are variables, I mean properties, or methods which are inside the class, and if you would like to refer to method or property which is inside the class, we use self. Self means the class itself. It means if we use self here, it means we use something which is inside the class code. Shape name, this is our property. If I would like to refer to something, some property or method inside the class, I use self. Shape name is here, so to refer to this I can use self and dot operator. We could use actually in Swift we don't need it. We could use only shape name, but it's much better to use this self because it simplifies everything, especially more complicated classes. Okay, so this is self method inside instance. First, this is the same story. Self means we refer to property or to method. In this case, this property W and H, and we have the properties here. Again, we use self to refer to properties which are inside the class. If there is no initializer, this init without the func before means this is initializer. It can be empty. Default initializer is just empty. There is nothing inside of such initializer. So without parentheses, you can see. But this is actually this would be additional one, so I got me errors here. We can remove it. So initializer as such is to create it, we use this keyword init, and inside this is just function, but very special function. But anyway, inside we have variables, actually property parameters, and in initializer we can set properties at the time of creation of object. So if there is no initializer, it will be default one is provided, which means default one is this one, just empty parenthesis. It means this is default initializer. We can have more than one initializers. We can have multiple initializers, and the difference between them is only in the list of parameters. So if they have different parameters list, it means they are different. We can define inside class several different initializer, and which one we will use, it depends on our code or our project. Very important thing, parameters in initializer, the names of parameters are automatically external. It means if I use width here and height during initialization, during creation of object, let's say object rectangle, I will have to use the same names for the parameters, which means, let's say I am creating a rectangle object, it's rectangle, and it will be, now I have initializer, and if I put bracket, automatically I can see initializer and inside the names for and data type for parameters. So this is very important thing. We have to use the same names for parameters, and they are automatically external. Here is example. I use width 3.4 and height 3.4, and rectangle areas method in my class, and I can refer to this method by dot operator. Very important thing, if I would like to use something from another class, I can do it by inheritance, and shape is my parent or base class. It's very simple here, and on top of that I can build something more. I can add some more, but it means I can use something which is in my base class. If I have function method set shape name and rectangle, is a kind of extension of this class shape. It means I can use as well methods and properties which are for shape class. And I can try to do it. As I can see, inside the rectangle class there is no set shape name method, but because of inheritance I should be able to use it. Let's see if it exists. Rectangle set shape name, as we can see, it does exist, because this method set shape name in rectangle class is inherited from shape class, which is the base class for rectangle class. Point 6, inside methods and init, which is a kind of function as well, parameter names are local, which means that if I use width here, and this would be width, and height here, and height here, the names width here and height here, and the width here and height here will be different, because I use it as a parameter names in function. Init is initializer is a function. It means the names here are local. So even if I use the same names, they are still here inside the initializer, they are local. So there is no need to worry about mixing of the names, but because they will be referred in different way. Inside this function, they are only local, even if we use the same name outside. So this is standard behavior for functions. So this is actually nothing special, but it's good to know about it. And obviously initializer can have default values for parameters. We can set default values. Here we don't have them, but it's exactly like with functions. We can use default values, and then we can forget about initializing exact values, because if this content here would be empty, some default values which we would set here, like for function, would be used here. So it was explained in functions lessons. So this is basically the same behavior for initializer like for every other function. Can default values for parameters. And now very important thing. Point 9. All properties must be properly initialized. It means that if the two properties width and height are not initialized here, they have no value here, they must be initialized here in initializer. This is very important, and only after fixing all properties we can use them in methods. This is very important thing. All properties must be properly initialized, because otherwise object will not know how it should look like, more or less. By the way, structures and classes are very similar, with exception that if you would like to make copy, we use copy if you would like to pass structure into function, and we use reference for classes. So this is the only difference, but as we can see, there is as well initializer for data structure. This very similar behavior for structures as well. Sometimes it's much better to use data structure than class. They are very similar, but the difference is that they are passed as parameters by value, and classes are passed to functions as by reference. And this is for point 9 as well. At point 10, self for functions only after initializing all properties. It means if you would like to use self, refer to some property inside the class, we can do it only if previously we initialized properly all properties. Only then we can use self. If we would not initialize it properly, it means there would be probably some problem. Yes, as we can see, there are problems. We have to initialize properly or properties. Self-initial all properties. And now very important thing and very useful. The point is that lazy property and computed property in class is very special. I mean, they can call instance method, but property initializer cannot. It means if we have lazy variable, it can call the method even if this is not initialized yet. But this is possible only for lazy variable. For normal variable it's impossible. We go straight away error. And it's possible for computed property, which is here. Again, we can use self and refer to method, which is down the code, even if this property actually is not set yet. But still we can use method and refer to this method by self. So this we could use only for very special kind of properties, lazy property and computed property. Sometimes this could be very useful. For normal property and for initializer we cannot use it, but we can do it for lazy variable, lazy property and computed property here. If I would like to do it for normal property, because actually this property here does something, obviously it shouldn't work, not only for this reason but for other reasons too, because it uses last name, which is here obviously. But anyway, if I would like to use method before I initialize properly properties, I can do it, all properties, I can do it only if I do it for lazy property or for a computed property. And here we have just example of our customer class, object customer 1. It's initialized. There is no initializer here, which means default initializer is provided. And I call here get name property, which is this computed property, and result is John Smith, because this is the value returned for this property. So everything is working here. I can use method to initialize property only if the property is lazy or computed.